Hi, this is Angela Galloway, and this is a lecture video for Math 146. This will actually be our last lecture video. This is for Chapter 12, actually the extension part of Chapter 12, so it doesn't really have a section number, it just comes at the end of Chapter 12. And this is an introduction to linear regression. And so you are going to need this, especially for your stats project, because the stats project does include doing regression. So this hopefully will help you to figure out how to do that, and then also how to just do linear regression in general for your homework. So an introduction to linear regression here. You know, when we were back in chapter 8, we looked at how 2 points or more than 2 points fall exactly on a line, and then we could calculate the equation of the line, etc., right? But in real life, most of the time, data doesn't fall exactly on a line. However, we do see data, you know, that falls in a linear pattern. So you can see that as x goes up, y goes up, or as x goes up, y goes down, or whatever. So you see a linear pattern emerging, and we want to be able to describe that data with a linear model. Okay, so let's look at this example. It's actually one we looked at a little bit back in chapter 8, but let's say a certain store looked at the square footage of 14 stores and the annual sales in millions of dollars for each of those stores. Okay, they want to see if there's any relationship between the two variables. So we could probably predict or hopefully say that, you know, the larger the store, we're hoping we would get more sales, right? If not, then there's no point in getting a bigger store, right? So that's kind of what they want to see. And maybe they're doing this because they're wanting to open more stores and they're looking at, should we buy a 1,000 square foot store or a 2,000 square foot or a 3,000 square foot? You know, what are our expected sales for those different sizes of stores, right? And so that's what we might be using this for. So the first thing we need to do when we get our data, really anytime we get data, the first thing you'd like to do is graph it in some way, okay? And we learned at the beginning of chapter 12 what types of graphs we could use. You know, if you have quantitative data, you could look at maybe a histogram. If you have qualitative data, you could do maybe a pie chart or a bar graph, whatever, right? If you're looking at change over time, you would do a line graph. Well, if you're looking at the relationship between two variables, the graph that you want to use is a scatter plot or a scatter diagram. Basically what that does is it just puts up the XY coordinates of each of your points, and then you're able to look at that and see if there's any shape to the data. You know, does it look linear? Does it look like a circle? Does it look like a parabola? You know, what does it look like? So when we put our data here into a scatter plot, and I'll show you how to do that in just a minute. We can do that in our calculator and also in Excel. But for now, let's just look at this plot. When we look at just the dots, so before we have the line here, let me erase that out. So a scatter plot just has the dots on it, okay? So we look at the plot and we say, you know, those look fairly linear. You know, I could draw a line in here that I think, you know, would follow that pattern pretty well. But just having the scatter plot here isn't enough, right? We're not going to connect all these points like this, okay, and then figure out anything with that. What we're going to try to do is we're going to try to find the equation of the line that best fits this data, okay? Now, how do I find the line of best fit? Okay, so like for example, if I'm looking at this here, um, this is the same scatter plot that I had from before. And so maybe I might think this blue line fits the data best. And someone else may think the red line fits it best, and someone else thinks the black line, and then we could draw lots of other lines in here for lines that we think best describes this data, the relationship between x and y. But how do we choose which line is correct? And so the way we do that is something called least squares regression is what we're using. And so we're looking for the least squares criterion. Now what that is, just very simply, so I don't, you know, want to go too deep into what this really is, but just a general idea. What we're trying to do is we're trying to minimize the errors. The errors are the difference in the predicted values of y, and the real values of y, okay? Like, for example, if I plug in a 3, okay, the value that I really got for y was this here, was about 4. But my lines predicted that when I plug in 3, I'm going to get close to 6. Okay, that's what my lines predicted. So the difference in where it actually happened and where I predicted it was going to happen is my error. Okay, that's the error in the line. And every line's going to have some error because none of these points fall exactly on one line, right? They're not going to all fall on one line. But if you notice, if I look at, let's say, the red line, this one, that point, there's very little error there, right? And this one, that one, there's not a lot of error. There's not a lot of error here. Now, there's some bigger error in some of these, right? But a lot of these, fall on the line, are pretty close to the line, so our error would be pretty small. So the way we're going to choose the best line is by figuring out which line fits the data best, okay? And so we're looking for the line that minimizes those errors between the points and the predicted values, okay? How do we do that? Well, this is the actual equation of the line. Now, I don't actually expect you to do this equation by hand, okay? Because one, it can be very time consuming, especially if you have a large data set. Two, it can be difficult because, since there's so many calculations in here, it's very simple to make one little mistake and then the whole problem's wrong, right? The reason why I'm showing you this is because if you look in your book or if you do the help me solve this on some of these problems, they may bring up these formulas, okay? And so I want you to know that yes, these are the formulas to get these by hand, but no, I don't really expect you to do that, okay? What we're going to do is we're going to do these either in Excel or using our calculator. Okay, so those are the two ways that I'm expecting you to be able to calculate this. So this is how we would do it by hand. Okay, here is my X values, my Y values. I do some of this stuff here to plug into the formula and I get this as my answer. Okay, but like I said, I don't really expect you to do that, so I'm not going to talk too much about it. But how are we going to do this? Okay, so let's first look at how we could do it in our calculator. Okay, so here's our calculator. I'm going to go turn it on. I'm going to go to Stat and Edit. That's where we always go to put in data, right? I'm going to put in my X values and my Y values, okay? So let's put those in. And of course, that's what's going to take the most time. If you have a really large data set, like on your homework or something, then it might be easier, to go ahead and open it up and put it in Excel like we talked about when we were looking at some of the earlier sections, how you could click that blue button and say copy to Excel. It might be easier to do that just so you don't have to type in all the numbers and possibly type in something wrong or whatever, okay? But that's up to you, whatever you feel most comfortable with. Okay, so I think we have all our numbers in here. Hopefully I typed them all in right. One thing you do want to notice when you're doing linear regression is at the very bottom, okay, look at the bottom of your to list. Make sure that list 1 and list 2, or whichever list you used, are the same length, okay? That's the first error the calculator is going to come up with. If you have more X's than you have Y's, or vice versa, then it's going to say error invalid dimensions. And if it says that, that means you probably, maybe you're pulling the wrong data set. Maybe, you put your data in L3 and you told it to look at L1, or you typed in something incorrectly or whatever. So check for that because that's a pretty common error that people will get. Okay, so we've got all our data in there. We're going to go back to Stat and go to Calculate, and we're going to do linear regression here, number 4. And so you can punch 4 here, or you can just push enter when you go down to 4. Okay, now the way mine's set up here, mine doesn't have prompts to tell you what to put in. Yours might have prompts that say where's the X variable, where's the Y variable. If it does, then that kind of helps you through it. If not, if it just looks like this, you just tell it where your data is. So you first put in where your X values are. Mine are in L1. then you tell where your y values are. Mine are in L2, and I'm going to push enter. Okay, and so I get this output. Now there's a few things missing here. I want to see the R values. You may see those and you may not. If you don't see the R values, then you need to do this next step. And once you do it one time, you shouldn't have to do it again because it should save it in your settings until you have to change batteries or something like that. Okay, so we're going to go down to the catalog here, which is the second function of the 0. So do second 0. And I'm going to scroll all the way down until I get to diagnostics on, which may take you a little while. Okay, once you get down to here, the diagnostics on, we want to push enter. Okay, and so it's turned it on. Now, if you do second enter and second enter, it's going to bring up the last things that you typed in, so you can do that instead of going back to stat and all that. So here's my linear regression, and I'm going to push enter, and this time I will see my R values there. Okay, and we're going to want those in just a second. Okay, but this is how I would get, that's my slope there. The A value is the slope, the B is the y-intercept. Okay, now how would I do this in Excel? Well, in Excel, I've got some other data in here. I don't know why I didn't put the data we were working on, but this is just some other data that I had. And this is the data that I actually use on the regression instructions that I have on Blackboard that show you just how to use Excel or your calculator for regression. So here we've got age, and this is income. So age and income, and that obviously is an incorrect number. I'm guessing that's supposed to be 40. Okay, so there's our data there. So what we do for this, the first thing we want to do is do a scatter plot. So I want to go up here to insert, and this one that looks like a scatter plot that has the dots, I'm going to choose that. And once I choose it, it really goes right to your data. It assumes that's, you know, the data you want to use. So here I'll look at that, and really I'm only doing this to look at it and make sure that it looks somewhat linear, you know, that it looks like a linear shape, that it doesn't just look like dots all over the place, or maybe a parabola, more of a shape or something like that. Okay, so I'm just looking for that linear shape there. Okay, so that looks good. So once I see the scatter plot is good, I know I can do linear regression. So I'm going to go to data and data analysis, which we've used a lot in this chapter. We've used it to calculate our histogram, and we've also used it for the descriptive statistics, right? So one other thing we can use it for is regression. So go to regression here, say okay. I want my input, the Y. Okay, so make sure you put in your Y's first. It asks for the Y's first. So here's my Y's, and then my X's. Where do you want your data to come out? I just want it right here. That's fine. Oh, and I clicked the wrong thing. When you click that, make sure that your cursor is in the actual box. Otherwise, it's going to go to where you were. So my output range, I want to be here. I'm going to go back here and get my Y's again because I messed that one up. Okay, now this, you don't really have to have any of these. I mean, you could click some of them if you want to see some of the other stuff or whatever, but you really don't need anything for what we want in here. What that's going to show you, if you do click that one plot that I chose, it shows you the predicted values here and your real value. So you can just kind of see how they fit together, you know, how closely it's going to fit. Okay, so you get a lot of output here. Okay, the first thing that you will want is this is our R value. Okay, so our R value there, it's called multiple R here, but that's going to be the R value, the correlation that we will talk about in a second. The next thing that we want is this. Okay, so this is our intercept and our x variable. Okay, so this is our slope and this is the intercept. Now all this down here is our residuals are just the error that we talked about before, the error in the predicted value and the real value. So this is the predicted y value, and then what actually happened, or the real y value, this is the difference in the two. Okay, so that's all that is there. Okay, all this other stuff is important, but not necessarily to us. We don't really get into all this other information. Okay, so that is how you would do it in Excel. Okay. Another thing I didn't show you on the calculator is how would we do a scatter plot on our calculator. To do the scatter plot, we've already got our data in. Okay, so you'd have to have your data in the stat edit, do that first. Then go to second y equals, so where we went to do box plots, and I guess box plots is all we've pretty much done in here right now. So turn on the graph, and we actually want that very first one as a scatter plot. Make sure you have your X and your Y list marked correctly there. And then just go to graph. Okay, you can see it pretty good right there that it looks linear, but if you can't really see it or you want to see a better view, go to zoom number 9, which is the zoom stat. Okay, and there we see our line. Okay, so we could, well, not our line, but we see that it follows a linear pattern, right? Then once we get our equation, if we wanted to, we could type in our regression equation here. So, you know, when we figure out our regression equation, maybe we want to see how well it fits the data here. So let me put in my equation and graph it. And there you can see that that line does look like it fits it, right? If you get a line that graphed up here or down here, then you probably did something incorrect because it doesn't look like it fits the data, right? So you can do that just to kind of tell that it fits the data correctly, okay? All right, so getting back to this, we talked about slope a little bit, and we did that, I think, back in chapter 8. Then we also looked at figuring out how to predict sales for a new store opening. That one, the only thing that was a little tricky is just making sure that you plug in 2.4 for the 2,400 square feet, because we're talking about thousands of square feet in this example. Okay, and that's why I used the 2.4. We plug that in. So we can use our regression equation to predict, predict what's going to happen in the future. And we're going to do some more examples, but let's look at some more things that we need to talk about with regression. Okay, let me move some of this around. I don't know why it's kind of off center there. Let me move this so you can actually read it. Okay, so what we're talking about here is if the problem you're working on doesn't tell you which variable is X and which is Y, then how will we know which one is X and Y? Okay, because we're saying that, you know, the way we graph X's and Y's, we say we plug in a value for X and that gives us a value of Y, right? That's usually how we worked in chapter 8, right? So what we're saying is that X is our explanatory variable, okay? The value we plug in for X is going to explain the value that we end up getting for Y, okay? So X is our explanatory variable or the independent variable, and I usually remember that because explanatory has an X in it, so that makes it a little easier to remember that explanatory is the X variable, okay? And so it's the variable that's used to predict or explain the values of the response. The response variable is our y, okay, and it is the variable to be measured or observed. So often we're going to have to determine which is our explanatory and which is our response. In the clothing store example we just did, the square footage of the store was the explanatory, and the response variable was the yearly sales, okay? Because we're assuming that the larger the store, that's going to explain your larger sales, right? And it wouldn't make sense to say it the other way, really. So here's just some examples of how to determine, you know, is it explanatory or response. So if we were looking at number of study hours versus grade on a test, obviously the number of study hours would explain the grade on the test, right? And that would be your response. So that's how we got those, is just kind of thinking about which one explains the other one. Okay, now those R values that we got when we were doing either in Excel or doing it on our calculator, the R value, let me see if I can bring this back up here. This R value here, that's our correlation coefficient, okay? And the correlation coefficient describes the direction and strength of a straight line relationship between two variables, okay? So it's telling us how good of a relationship X and Y has. So how good is X at predicting what Y is going to do? Now, R values are always between -1 and 1. The sign of R should be the same as your slope. If you have a negative slope, you should have a negative R value. And now I have noticed that in Excel, for whatever reason, their R values are always positive. Okay, so if you have a negative slope, if you see the graph of the line looks like this, so it's falling from left to right, then your R value should be a negative. So even though Excel gives you that positive, go ahead and make it a negative. But your calculator should give you the positive or the negative correctly. The closer our R value is to -1 or to 1, the stronger the relationship is between X and Y. The closer the R value is to 0, the weaker the relationship is, okay? R values and the regression equation are not resistant to outliers. So if you do have an outlier, you know, a really extreme high or low value, then that's going to pull the R value down and it's going to pull your regression equation down or up, depending on which way the outlier is. So it will affect your regression equation. And then again, remember this only measures linear relationships. And so where we kind of notice that is down here when we're looking at these two examples. Both of these, notice, have an R value close to 0, okay? But one of these kind of has no relationship, and the other one has a relationship, it's just not linear, okay? If you get something like this is something we would call just random scatter. So, you know, sometimes when I have a low value of X, I get a low value of Y. Sometimes I get a high value of Y, okay? So it's hard to predict what Y is going to do. Because it's kind of all over the place, okay? So that would have an R value close to 0. There's no linear relationship. There's really no relationship between X and Y. This, on the other hand, there's no linear relationship, but we definitely can see a relationship between these variables, right? It's just not linear. There are other types of regression. We don't have time to go through them in our class, but you can do, you know, exponential regression, quadratic regression. There's lots of different types of regression that you can do. It's just in our class, we only have time to do linear. But just if you were to see data that look like this, you can't do linear regression on it, but you might be able to try another type of regression. And in our calculator, it's not any more difficult to do another type of regression. You would go to Stat and Calculate, and you notice here all these are different types of regression. We have quadratic, cubic, quartic, um, then we have exponential regression. Okay, so we have other regressions that we can use, okay, just so you know that for the future. If you do take a Math 150 class in the future, you'll talk more about that too. But going back to our other ones that are looking linear, this and this, of course, would be perfect relationships. So all the points fall exactly on a line. That's obviously not going to happen much in real life. But if it was to happen, your R value would be equal to 1 for a positive relationship or -1 for a negative relationship. Everything else is kind of in between there. The closer it looks to this, the closer our R value is going to be to 1 or -1, right? So this is like an R of 0.9 or -0.9. This one, it has a little bit of a relationship. I mean, you can see kind of as X goes up, Y goes up, but they don't follow that line as closely as this does. So this would be an R value around 0.4 or -0.4, okay? All right, so how can we use that correlation? Well, you just have to be careful with correlation. If you have a high correlation, so X and Y are highly correlated, you can't then jump to the conclusion that X must have caused Y to happen. Okay, so we talked about this at the beginning of chapter 12, the difference in correlation and causation. Okay, and we said really you need an experiment to be able to prove that X caused Y to happen. If you're just doing observational studies, then you're really just showing that for whatever reason X and Y are correlated. So, like for example, this graph here, we're looking at fresh lemons imported to USA from Mexico, so fruit imported from Mexico, and then total US highway fatality rate. And so the more lemons we import, the lower our fatality rate is. Now, does that mean that we should import more lemons because that's going to decrease our highway fatality rate? No, of course not, right? Now, they might be correlated for whatever reason. They have a very high R value, but that doesn't mean that one thing caused the other, right? This one here, autism and organic food sales have a very high R value. Does that mean one's causing the other? Well, I don't think so. You know, I mean, we could do an experiment and maybe see if there's any relationship there, but I don't think one is causing the other to happen, right? This is another example with global warming, looking at maybe not necessarily as one thing causing the other, but trying to figure out which is the explanatory and which is the response. So many scientists have said that, you know, as we increase our carbon dioxide, that temperature is increasing, right? So we need to decrease our carbon dioxide so that the temperature comes down. However, some scientists, when they look through this graph, they say that actually it's the temperature rising that's causing carbon dioxide to rise. So it's a difference in which one is the explanatory variable and which one is the response, okay? And that's a little video, YouTube video there, kind of explaining a little more on that. Okay, so doing another regression equation. This is the one I think I just did over in Excel. That's the data set that I had. So for this, we want to know what would be a 50-year-old resident's income in this small village? What would we predict it to be? So when we're talking about prediction, we have to create this regression equation. We're going to do linear regression. The first thing we're going to do is figure out, is this explanatory or response? Which one's the explanatory, which is the response? So we would say age is explanatory, and then income is the response variable. Okay, that was our scatter plot. We look at that first to see if it has a linear shape, which it does. Once we know it does, then we can calculate our linear regression equation. We do that, and this is what we get by putting this into our calculator. Or you can see in Excel here, this was our regression equation. And I think it's a little off, so I must have typed in a number wrong somewhere, but that's going to be pretty close to what it is. That the 89 there is our slope. Here I have 90.15, so I must have just typed in a number wrong when I did that one earlier. And then this is going to be our y-intercept, okay? And so you should get that from putting it in Excel or doing it on your calculator. Okay, here's another example. We've got height and weight. So the first thing we do is say height is going to be our explanatory. Um, sorry. Okay, so height is our explanatory, weight is our response. Find the equation of the regression line for this data. We put this data into a list, this data into a list in our calculator, or put them both into Excel. We calculate our equation. What is the correlation between these two variables? That's our R value. So this one, you know, it would be a positive linear relationship, right? Because this is a positive value, our slope is positive, and it would be a moderately good relationship because it is closer to 1 than it is to 0, right? So it's a okay relationship there, 0.66. Then predicting, we plug in this value of x into our equation, and we predict that a 64-inch tall man would weigh about 136 pounds. Okay, these are some more examples from your homework, what your homework ones kind of look like. You'll notice that when you're doing these in your homework, remember that this little blue box here up here. If you click on that, it'll open it into Excel if you want to. So then you'll have your data already set up in Excel, and then you can do that data analysis and do the regression. This one doesn't actually ask for the regression equation. It just asks for the predicted maximum heart rate, right, of a resting heart rate of 41. So we have to find the regression equation, even though they don't ask for it, to be able to predict. Okay, so we find that regression equation using our calculator or Excel by putting these into list 1 and list 2 there, and then we get this answer here, 163.96. And that is our last slide for 146. Isn't that exciting? Okay, so if you have any questions about the regression, let me know. I do have the instructions for how to do regression in Excel and your calculator as a handout that's saved in Blackboard in the class notes area, so you can get that if you need it. If this tutorial wasn't enough, the little bit that I did, maybe look through there and it'll take you step by step. You can also probably find lots of YouTube stuff if you just type in like Excel regression. You should be able to find lots of other videos that have been done for that. Or if you want to do more, if you need more instruction on your calculator, type in TI-83 linear regression, something like that. You should get some more videos you can look through. Okay, so this is the end of chapter 12. You will be using this information, of course, for your stats project. So if you have any questions about any of that, please just let me know. You can always contact me at angela.galloway@kctcs.edu. Thanks.